everyone, my name is Joe Adunai and this is my official unofficial solution for the network state exam. Now this is the 26th topic, which is about VLAN trunking protocol. Mainly for this topic I covered the half of it, I believe, in the previous video, in the previous topic, so please check it because I'm just going to reference to that in a lot of parts. The concept and operation of trunking, advantages and limitations, I've talked about this in the previous video, that why we are using trunking and what's the advantage of it. So basically we can send several tagged traffic from one switch to another switch if they are configured with a trunk link. So basically a trunk link can transmit traffic that has a VLAN 10, 20, 30 tagged frames with frames. That's all. And I don't know what's the limitation. If it has a limitation, maybe it uses more bandwidth, I don't know. VLANs and trunk link, establishing trunk connection on Cisco switches. So I talked about VLANs and trunking, why we need in the previous one, so please check it. Establishing trunk connection is basically connected with the port modes and the DTP, because if we set a port, we have different ports. As I said in the previous one, usually at the end devices where we are accessing a VLAN to an end device, then those ports are called as, so basically, let me visualize it. Basically these ports are set to access ports because there we define that which VLAN traffic they are accessed. So basically we define within the VLAN trunking or within the VLAN ports two states. Either there is a trunk link state, or there will be a trunk link, or it will be a non-trunk state. So please, if I'm going to miss or say something silly here, please check this in at Netacode, because there it's described. Basically we have, if I remember well, some approaches. Don't forget that this is the base of the whole VLAN, so that's why I do not delete this. So if I remember well, if there are two access ports, then that will be a non-trunking link. If there will be a trunk port, there is a port, and the other side there is another port, and this one is determined as a trunk port, then regardless of this port, the link will be a trunk link. There is a port state, the dynamic desirable, which actively tries to do a trunk link. So if the other side, this port is dynamic desirable, then this will be a trunk link. Or if this port is a trunk link, if this port is set as a trunk, then this will be a trunk link again. We have the dynamic auto, if I remember well. If both ports are set to dynamic auto, then that will be a non-trunk link. Or the one is a dynamic auto and the other is an access, then that will be a non-trunk link. And I believe, or I hope I covered everything. So you have to just check these communications that as I said, if something is trunk, then we don't care the other, that will be a trunk. Then the desirable would like to actively make a trunk link. If the other side is a trunk or desirable, then that will be a trunk link. And if one port is an access port and the other port is desirable or dynamic auto or access, then that would be a non-trunk link. Basically, that's the connection between the port modes. So of course, the DTP, what does this trunking approach, because when you set one port to a trunk link, then the DTP, the dynamic auto, the dynamic trunking protocol will do or will help in this process to make this as a trunk link. So of course that's the weakness of this whole stuff, that the DTP is automatically enabled. So if you set this one, no, just don't set this port, goes to a switch, and this port goes to a hacker computer, and the hacker, as I said, it's not a best practice, but the hacker will do a trunk link to the switch and will do this port as a trunk link. Then due to DTP, this link will be a trunk link. Therefore, the attacker can immediately access the switch to which the attacker should never been able to attach. But with the help of DTP, it will automatically attach or can use the other switch. So basically, that's the operation of DTP and the port modes. The operation frame format of .1q protocol is exactly the same what I've said in the previous one, because .1q protocol is the tagging. So basically you have to tell what I've said in the previous video, so please check that. The important stuff here is the purpose, functions and usage of VTP. I don't know what's its full name. So we have this VTP, and of course the advantage of it is the administration, because imagine a small company where we have 3 switches. As I said in the previous video, we have to configure all the VLANs manually on all the 3 switches. Of course, this can be easy if there is a small network where there are small or low number of switches. But imagine a network where there are 10 switches. That still can be considered as not too many switches, but for example, implementing 5 VLANs on all switches, that's 50 VLANs as a sum. There can be a misconfiguration, and then imagine a large company where there can be 100 switches, and by just simply implementing 3 VLANs is 300 common at least. Therefore the misconfiguration is increased there. The VTP will help to avoid this, because if we enable VTP on the switches, then if the administrator simply creates a VLAN or modifies or deletes a VLAN on one switch, then due to VTP or with the help of VTP, this will be synchronized on all over the switches. Therefore, on all the switches, the VLANs will be created, modified and deleted. That's the whole aim of VTP, and that's its advantage. The disadvantage that it is working on a number. What's the name of the number? Okay, I don't remember the name of the number. Yeah, I don't remember the name of the number. So the VTP is based on a number like the sequence, not the sequence, but like a priority number. I don't know its actual name. I'm going to write it down in my YouTube video to tell you that. So it's using a number, and it's quite simply that when a new switch has been attached to a network, then this number is revision. It's using a revision number, if I remember well. So by default this number is 0. So it's simple that we have to define this VTP domain, and the first packet that it will receive will update its revision number and will use that from that moment. But if we are using a switch that has been already connected to a network and we are connecting to another network, it is possible that when a VTP traffic will comes to it, it will not accept it because it has a higher revision number than the previous one. Like, you don't want to read the yesterday's news today, so you are not going to accept it, so the switch will not going to accept it, and there will be problem. The revision number is the weakness or the limitation of VTP, and if I remember well, with the VTP, if an attacker attaching to the switch and will send a traffic first, then the attacker will set its revision number and can use this as an attacking approach as well. The concept, operation, configuration of VTP, I didn't know the operation, I told everything about VTP, so I believe that's enough. common misconfiguration, I don't know. The pruning is quite important, or it's quite easy. That what VTP pruning means, that imagine we are having 3 switches and they are connected, and imagine that the first switch has a port to VLAN 10 and VLAN 20, and the last switch has the same port and access port to VLAN 10 and VLAN 20, and the middle switch has a port to VLAN 10. So what does it mean? When the traffic will come here, for example, a frame that's tagged with VLAN 20, then that will be passed to this switch, even though this switch will not forward it to the next switch because it has nothing to do with VLAN 20. So with the help of pruning, we can ensure that we will put here like a blockade or a wall, because it will seem this switch will simply not forward VLAN 20 traffic to the second switch until the second switch has something to do with VLAN 20. That's the approach of the pruning, and of course this will improve the security, that not sending unnecessary traffic, and of course it will use less CPU if the switch does not have to process that. So it will simply improve the security, I believe, that unnecessary frames will not be sent while they don't have actual access to these ports. So that's the base of the pruning. And I believe that's all about this topic. I've said everything in the previous video, and now I just extended this with the DTP ports and VTP. So that's all. Again, if I said something wrong, then I don't really care. And don't forget to subscribe to my channel.